Hello guys, welcome to my YouTube channel ML Cuddler Mohit. This is Mohit Kumar. Generally student calls me M.K Sir. So as you know guys, I have been into the field of data science, artificial intelligence and machine learning for last 8 years, and this YouTube channel I have created to share my experience and knowledge related to the data science and machine learning with all the data science enthusiasts. So I am here with a very interesting and informative video guys. It's not just a video, it's actually a part of faculty development program which was organized by Chandigarh University to enhance the skill of their faculties. So they invited me to talk about all the experience which I gained through last 8 years guys, and definitely to talk about how industry is utilizing the applications of data science, artificial intelligence and machine learning, right? So definitely throughout this video I'll be talking about lot of things related to the data science world. So like I'll be starting with the analytics and different stages in the analytics. A lot of people are already working in the field of analytics guys, but they don't know there are 5 different stages of analytics, right? And after that I'll talk about data science, different components of it, and very important slide about the data science toolkits, right? So there are a lot of technologies in the data science and it's a very dynamic field as you already know. So there are a lot of programming languages like R and Python. So I'll be talking about what are the different where R is better than Python or where Python is better than R, and definitely from my perspective based on my experience I'll be talking which programming language is the winner, right? And definitely there are a lot of topics which I'll be talking about throughout the session. So guys, definitely this session is going to be very informative for all the data science enthusiasts who are planning to start their career in the data science, or who have already started preparing for the data science world, or who are already in the data science world, right? So definitely this session is going to be very informative for all of you. So guys, without further ado, let's get started. And one request guys, so please be patient as this video is bit lengthy. It's almost like 1.5 hour lengthy. So but definitely guys, this video will keep you engaged. So let's get started and let's meet at the end of the video guys again.
So one and all present here today for first day. Our external expert is from industry. He is from Z Entertainment. He is working as artificial intelligence expert. He is Mr. Mohit Kumar Saini. So welcome, sir. Mohit Kumar Saini have Mohit Kumar sir have extensive knowledge of data science and machine learning. He is graduated from National Institute of Technology, Kurukshetra. Then he did his master's from IIC Bangalore in business analytics. Then he have complete experience in data science and machine learning. He worked as data scientist in the Jubilant Foodworks, Bounce, Infosys, and Siemens. Now I would like to invite Mr. Mohit Kumar, our first expert from the Z Entertainment.
Welcome, Mohit sir. On behalf of Chandigarh University, we welcome you to the first day of the 5 days FDP. Thank you, sir.
Thanks, Vikas sir. So it's my privilege to be here, and I'll try to keep it more interactive, as sir already mentioned that we'll try to keep it more energetic. So that will be my.
Thank you,
Mohit
sir.
Now you can share your screen.
Yes.
Okay. So shall I start with the
Yes,
session?
definitely, sir. Yes. The
Okay.
audience already have joined. You may please take over the session now.
Sure. So good morning, everyone. As I already mentioned, yes, as Anu sir already mentioned, I started my I did my BTech from NIT Kurukshetra, and it was in mechanical industry. So I did not have any background in the programming then, but I was very much interested in mathematics. I was good at it. So I planned to do masters in statistics, right? So that was the intention. And then I found out there is a course in IISc where we have more on the statistics, which is a major, and then in the business analytics. That's how I got to know about business analytics field. And it was very new at that point of time. There were not very there were very few colleges who were providing analytical academics, right, or the degree in the analytics. So I started my career with different I did my masters from there, IISc. Then during my masters, I worked in a couple of companies like Unisys and Citibank. Then I started my career with Infosys, Siemens Healthcare, Bounce. So in Infosys, it was more into the metro retail domain. In Siemens Healthineers, it was more in the healthcare domain. Then Bounce, it was a startup in Bangalore, which was more into mobility solution provider, right? So that was a transportation domain, I would say. Then I worked for almost 2 years in JFL, which is a master franchisee of Domino's Pizzas and Dunkin' Donuts. So it's more into QSR, quick service restaurant, right? Where we deal with the customers and we try to personalize the customer experience. And last, like 2 months back, I joined Z Entertainment, where I'm handling the recommendation. So recommendation on Z5 app. So most of you would be using Z5, right? You already know about Netflix, Prime. So in India, Z5 is a competitor for Netflix and Prime Video. So I'm handling all the recommendations you get on Z5 app, right? So you may find like movies you may like, next items, right? All those are working. So those algorithms, those recommendations are generated through recommendation systems, recommendation algorithms, and the major part I am actually taking care of that. So you can see different domains, and I'll be talking about those different domains with the different applications over there. So my idea is to give a feel how data science is being used in different industries, whether it's retail, recommendation, ad tech, OTT, different domain, same field, but different applications, right? So I'll be giving you the flavor of those. So here are my few role models, which I always follow to keep myself updated. And I always present this to everyone, whoever attends my like sessions, right? So I would say who are into more academics, I will definitely recommend to follow these people because they are the pioneers or the expert in the field of AI. So on the top left, so if I ask a question, anyone who can, who is aware about the guy on the left top? Anyone? Like you can write it in the chat window so that I can understand. So any, like out of these four, anyone you know, you can write the name.
Sophia the robot?
Absolutely. The last one.
Yeah.
Absolutely. What about three?
Don't know, sir.
Andrew and G.
Andrew NG, absolutely. On the right top, it's Andrew NG, Sophia, and these two. No problem. Let me start. So the first left. So sir, just forward it one click. Yeah. So he is DJ Patil, Dhanurjay Patil. So he was the guy who actually coined the term data science in back 2008, along with another guy, Hammer Becker. So when he was working in LinkedIn, he was leading the team of technology over there. So at that point of time, these two people actually coined the term data science, and he was the former chief data scientist at US Office of Science and Technology. So he was formulating the policies, and those policies for US was formulating based on the analytics, based on the data science. So if you want to understand like how government uses different data science applications, definitely you can follow this guy. You can like go through different interviews he has given. You will be able to understand how government uses data science. And data science is everywhere, guys. Wherever we have the data, we have data science applications, and that you will be observing throughout this session. That is the agenda of this particular session from my side. So after this, back, sir. Yes. So the second, Andrew NG, everybody knows about him. So he is the founder of Deep Learning AI, Landing AI, Coursera. Most of you will know him from Coursera website, right? So, and the machine learning specialization he has given on the platform. So this was state of the art. I mean, as of now, that was the best course I have seen personally over online. And like he has been there for last 40 years in the machine learning field, and he primarily he has worked on the autonomous vehicle, right? So if you want to understand how this AI is revolutionizing the field of automation, then definitely you can follow Andrew Ng. Lot of papers, more than 200 papers in the related to the automation. Then the third, bottom left, Geoffrey Hinton. You know about deep learning, right? So deep learning is getting like very popular these days, and definitely it's the future. So now Geoffrey Hinton in 1986, he published one paper on backpropagation. Who already know about deep learning, they will know about the backpropagation, which is the foundation of artificial neural network, right? So he was the guy who was responsible for that ANN, a artificial neural network. All the applications, all the variant of artificial neural network, the foundation remains the same. That is your backpropagation algorithm, and that was given by Geoffrey Hinton. He was the mind of Google Brain team. So he has been there in the field for last 50 years, and definitely related to deep learning, specifically into computer vision. If you are interested, you can follow this guy and can be like stay updated in that particular field. And at the end we have Sophia. So why I have included Sophia here? This is the state of the art as of now. If you look at the AI, this is state of the art application or the example of AI right now. So like there are a lot of buzz things happening around Sophia, like she got or like it got the citizenship of Saudi Arabia, right? Yes. So let me set up the agenda of this particular session. And guys, if you have any question or if you have any another thing you want me to add, we can add that, no problem. So this is what I have planned for this session. So we'll start with the analytics from the industry perspective. What are the different, what is analytics and what are the different stages in analytics? Then why the data science is getting popular. A lot of people are there, but we'll try to unveil like why data science is getting popular now, not in the past, right? And what are the different applications of data science across different industries. I will be taking like more than 7 to 8 industries, and then in those industries I'll be talking about the applications. Then machine learning and different types. Then typical data science project life cycle. So when you work on any particular machine learning problem or data science problem, so there are typical steps which everyone needs to follow. So I'll be talking about those 6 steps which will frame the every data science project. Okay. Then different data designations. So there are a lot of designations in the field. A lot of people do not understand, like there are data engineers, there are data analysts or business analysts, there are data scientists. Now what are the differences in those designations? What are the different skills which are expected from these designations? So I'll be talking about those. So this was one of the feedback from my last session, so I just incorporated in this particular session. So then at the end we'll be talking about AI versus machine learning versus deep learning versus neural network, right? So I'll be talking about these 4 technologies which are there in the artificial intelligence. And definitely at the end we'll talk about deep learning applications as well. So it's going to be very informative, guys. So if you have any question, please write it in the chat window, make it more interactive. So yeah, next slide please. So business analytics. So everybody knows about analytics, right? So we are passing the data and then getting insight out of it or making inference out of the data so that the companies can make the business decision out of it. Let's say as I am working in Z5, so we have customer watching history data. So you are using Z5, that data, which particular movie you have clicked, how much time you have spent on the app, right? Everything you do on the app, we are able to store that data in the backend, and we are analyzing that data to understand your behavior, to recommend you new items, to make you more interactive or engaged with the app so that company can make revenue out of you, right? Ultimately, the idea of analytics or the application of analytics are around generating revenue or making user experience much better, right? So that's the whole agenda of every data science project. Either get the revenue from the customer, or like getting a business perspective out of it, or giving a better service to the customer or to the user of the product, right? So ultimately analytics, getting insight out of the data. Now there are different ways or processes through which you can get the insight out of the data. So you know about statistical analysis. In statistics you have a lot of like descriptive as well as predictive modeling. So you have linear regression, logistic regression, all those different models, statistical models, which help you to predict the future, right? Then this is the most important slide, I would say, analytical stages. So all the applications out there in the market related to the analytics, you can divide them into 5 stages or five different type of analytics. So it starts from the descriptive analytics. In the beginning of analytics, we always focus on the descriptive analytics. So in descriptive, we try to understand what has happened in the past through the data. After descriptive, we move to the diagnostic. So I'll explain all of these in the next slide with the example. So here, these are the 5 stages. So first, descriptive, as I said, what's happening in my business or what has happened in the past. So if you take example of Amazon or any retail company, they have the transactional data. Now from the transactional data, they can understand what was the sale last month, right? What was my top product who was sold in the last month, last week, right? Now what was the like CAGR of the company, like how well it is growing from the last year. So these are different descriptive stats you use to perform or to understand what is happening with the business, right? So this is descriptive. So all this mean, median, mode, where you try to summarize the data, those kind of numbers we use in the descriptive statistics. And it was the past where we were only focusing on the descriptive. Then after descriptive, it's the diagnostic, where we are trying to understand if there is a increase in the sale, which particular product is like behind that particular increase, or if there is a decline in the sale, why it is happening, whether customer are churning, customer are not buying the product, or is it the quality of the products which are declining. So all of these factors you try to understand, and then you find out what was the reason behind what has happened in the past. So diagnostic is always the second step after descriptive. Now you understood that there is a decline in the sale. Then what you will try to do? So you will be predicting what is likely to happen in the future. That is the third stage of analytics, predictive analytics, right? Where we try to predict the future. So like if you take example of Amazon, then definitely forecasted the sale of different products. That will be part of your predictive analytics. Or like which particular product is going to be sold more, right? So based on that, you can make a business decision. The business decision part from the analytics and the predictive part which you have performed, that comes under the prescriptive analytics. In prescriptive, you try to understand what should I do next. You understood the past, you also got to know about future. Now what you will do, you will take business actions that will come under prescriptive analytics, right? So this was there for long time because every analytics ultimately converted into business actions, right? So prescriptive. Now the future, where we are going. So these 4 are happening right now as well in every company. Predictive, descriptive, diagnostic, prescriptive, every analytics we are using in every industry. Now the next step where we are heading towards, that is cognitive. So this is the final stage where we are planning. So here, so far, we were making the decision ultimately, or based on all the analysis we have done, or based on all the machine learning algorithms, or based on DL model implementation, we take the action. But now in the cognitive stage, can machine take those actions, right? So in the final stage, we always have a human intervention when we are implementing the business logic. But here in cognitive stage, we are avoiding that. We are trying to, or we are allowing our AI machines or systems to take the actions or take the decisions. Okay, so these are the different 5 stages. Any questions so far? I hope this part is clear.
Yes, sir. Clear, sir.
Okay, thank you. Now the next part, why this data science is getting popular? What is the evolution, right? What's happening behind the scene of data science? So there are multiple reasons why data science is getting popular, and everyone wants a data scientist or business analyst in the industry. The first very important reason is technology evolution. So if you try to understand from this particular slide, you will be able to understand the technology evolution. You already know that. I'm just emphasizing on this particular part that we are evolving on the technology side. So if you talk about 1990s and the current time, we had landlines, now we have smartphones. We had computer of this size. Right now we do not have any storage space. We already, like, we store the data in the clouds, right? We used to talk about RAM of 256 MB. Even I, like, when I bought my first computer, I had 256 RAM, I think 256 or 512 RAM, MB RAM. But now we talk about TBs, and we do not talk about CPU. We talk about GPUs and TPUs, right? So that is the evolution. And on the right side, we had Ambassador at that point of time. Now we talk about autonomous vehicles, right? So that's the evolution in the technology side. Just for the fun side, evolution on the computer and human, this is how it's happening. Just for the fun fact. So next slide. Yes, so one we talk about, that is technology evolution. The next part is IoT, right? We talk about lot of smart appliances like your AC, your smart homes, all itself, like lightning, all the electronic and electrical appliances are being communicated with each other through the internet. So now those are nothing but part of IoT. IoT is a platform where all the devices are connected through the internet, and through internet they are able to interact and exchange the data with each other, right? So now if you talk about AC, they are able to tell there are sensors inbuilt in those, and those sensors get the data of the surrounding and process it or communicate through the internet, and then based on that finalize, like, fix the temperature, optimized temperature of the room, right? So this is part of IoT. Lot of things. If I talk about my bounce company, which had a very wild, like, if anyone have visited Bangalore in last 2 to 3 years, they would have seen bounce one scooty, yellow scooty. So they had a very wild business idea. So you can take a scooty from anywhere and you can drop it anywhere. There was no human intervention. There was no fixed location where you need to park or where you can get it. It will be anywhere. The scooty will be anywhere, right? So that business model was totally dependent on the sensors, IoT. So through the sensors, we were getting the data about the scooty, and we were trying to analyze that data to understand whether condition of the bike is correct or not, right? So this was very interesting business idea I worked upon. So the only reason behind that particular business model, why it was working, it was because of IoT. Now IoT made the data evolution, right? The first reason we talked about technology evolution. Now we are talking about the data evolution. Through the IoT, we are able to generate a lot of data. If you talk about a single air flight, right? There are more than hundreds of sensors which are implemented in the aeroplane, and through all those sensors we are getting the data, and in the real time we are analyzing those data to understand the condition of the airplane, whether it is in the right, like you can take example of like fuel, how much fuel is there, or there are a lot of gyroscopic sensors inbuilt in the aeroplanes, right, to understand the movement of the aeroplane. So how it is happening? It's happening because of the IoT, and through IoT we are able to generate a lot of data which we can analyze, we can get insight out of it, right? The next reason, or the major reason behind data evolution, is social media. We are on lot of social media apps like Facebook, right? If you talk about WhatsApp, Instagram, LinkedIn, Snapchat, lot of social media, we are actually surrounded by social media apps, right? And we spend a lot of time on those. When we are spending our time, we are communicating with others, we are giving our data. So when you are uploading an image on the Facebook or Instagram, that's a data for the company, maybe image for us, our pic for them, like for us, but that is a data for Facebook. And they are trying to understand, like a lot of applications you would have seen, photo tagging on Facebook, which came in 2014 or 15. So photo tagging, where you upload the pic, Facebook will be able to identify who is that person in the pic, right? Classic example of deep learning. So lot of things, they are analyzing the data. You take example of Netflix, they exactly know what type of movies, which particular hero you like, the director or actress, which particular genre, whether you like the comedy one or you like the horror one, right? How do they know? Because they are analyzing the data when you are interacting with their app. That's what we are doing in the Z5, right? All the data we are actually dumping in our database, then we are analyzing those to understand the preferences of the user, right? So a lot of stats or numbers are given here, and these numbers are actually from like 2 to 3 years back. Now that number has increased, so you can still feel like in 1 minute how much data we transfer through different social media. Like if on Facebook, if you take example, in 1 minute we share more than 3 million items. And if you talk about likes, in every 1 minute there are more than 3 million likes happen on Facebook. If you take example of any other, like Netflix, more than 69,500 hours of video being watched on Netflix in 1 minute. If you sum up all the users data, then you get this number, right? So I hope you understood that the evolution of data is happening. One of the major factor is social media. So IoT and social media, two major factors for data evolution. And then if you take any industry, data is there. If you take example of banking and finance, customer data is there, transactional data is there, your credit card history, based on that lot of applications, right? Like giving you the loan, giving you the loan and the amount of the loan, both of them are being generated through analysis they have done on your past transactional history of your credit card, of your debit card, right? All those data is being analyzed, and then they have finalized like how much loan you can, how much loan they can give you, and what could be the interest rate. As of now, there are a lot of like, I was going through one of the it was a conference, so they were talking, as of now if you see, interest rate are fixed for everyone, right? Most of, like for all the banks, the interest rate is fixed, but in the future interest rate will also be personalized. Like maybe in the future I will be getting 7.2% interest rate on the home, right? Or maybe someone else will be getting 6.5 or 8.5 based on the past history or the credit score of the customer, right? Very interesting application, right? Now if you talk about media and entertainment, like our Z5, Z Entertainment, we are into the media industry for last more than 3 decades. So all the data, watch history, customers, which particular movies. So all that data is being captured and analyzed. Healthcare domain, we are moving towards the EMR, electronic medical records, where we will have all the record of the patient history electronically. We will not have like paper one. So like in India, it's still there, but definitely in US, lot of provinces, they have moved from paperwork to digitally. So what is the advantage? Digitally, first of all, they will not lose the data. Second of all, definitely they can analyze the data and they can understand in different countries how the different workflows happens. Then education, again, you take example of an academy, they are recommending the courses, they are recommending the videos, and definitely they can understand the preferences of the they can understand the learning style of the kids or the students. And if someone understands the learning style, they can customize the course, and after customization the learning will become easy. And that is the agenda of every edtech company, right? Amazing application. I have worked on that side and it's a very interesting one. So similarly, after that we have government. They are actually handling our every type of data, I would say. Definitely BJP, after going through like Aadhaar card and lot of these digital initiatives, they are able to get all the data related to finance, personal, everything they have. Transportation, insurance, retail, every domain you take, we have lot of applications. Next slide, please. Yeah, just make it fast forward. Yeah. So this particular slide, the idea is the evolution of data science. Definitely it's happening there, and we understood why it is happening. But on the technology side, in the data science field itself, how things have changed from the past and right now. So in the past, we were more on the structured data, right? In the past, we had SQL databases like Oracle database, MySQL database. All of them are structured databases where we are storing the data in the form of rows and columns, right? But now if you talk, we have more unstructured data. So out of like, based on the numbers, so 80% of the world's data is semi-structured or unstructured. Unstructured, those are nothing but your unstructured data. Audios, all of them comes under the category of unstructured data. In the past, we were analyzing only the structured data, but now we are analyzing, we have the capabilities and techniques to analyze unstructured data as well. So on the data storage side, we have moved from SQL databases or relational databases to the no SQL databases or even clusters, big data clusters, servers like Hadoop, right? So now we have MongoDB, we have Cassandra, we have HDFS, we have HBase. All of them are example of NoSQL databases and distributed systems. Data quality, again, different type of data we can store in these, and different level of data, different volume of data we can store in these technologies, right? Predictive modeling, we were more specifying on descriptive in the past, but now we are talking about the predictive modeling. We are trying to predict the future. Every company is trying to do that. All the 5 or 6 companies I have worked on, our idea was to understand the customer's behavior in the future, whether the customer will click on a particular ad, whether the customer will buy the product or not, what kind of product the customer will buy. So all of that was part of predictive modeling. And for them, we have different tools now, like R, Python we use in general. But if we have big data, then we have different big data tools like Spark, where you can use like a different language, PySpark, I mean Python for using PySpark. R also you can use in the Spark. The Spark was built using Scala language, which is also the future. I have observed, and a lot of conferences are happening around that. Definitely Scala will get boom. Like there was a period where Java was very popular. If I talk about 2008, 2007, in the future, big data will be evolving. It's evolving right now, but in the future it will be booming. Definitely. definitely. So Scala will also be there. Then different tools like Mahot, where we can use like machine learning approaches. Then computation. Earlier we had CPUs and like RAM was in MBs, but now we have GPUs, TPUs, and we are talking about super machines like in RAM in TBs. Pattern findings. Earlier we were more focusing on like descriptive measures, but now we talk about deep learning techniques, machine learning algorithms, right? So now that is the transition from the past and the future, which makes your combined data science, right? So data science, I mean the bookish definition you can read anywhere, but ultimately idea is getting the insight like analytics, but there are more additional factors which comes under data science. So collecting the data, that also a part of data science. Processing the data, storing the data, creating a complete pipeline of the machine learning project, that those all comes under this data science, right? So I would say analytics is one part of data science. If data science is like an umbrella, then the analytics is just one part, and there are other components which are around this, right? So now basic things which everyone should know to become data scientist. So different major components of data science. First of all, definitely someone should have a good mathematics background, linear algebra specifically, like matrix manipulation or eigenvalues, all those things. One has to be very comfortable with. Then statistics. When you combine these two, you get machine learning. Machine learning is nothing but a combination of linear algebra and statistics, right? And then to implement these techniques, like you built one algorithm mathematically, now you have to implement it. For that particular purpose, you need computer science, any programming language, R, Python, or any. You can use Java, C, C++. I have seen, so you can use those as well. But Python is the best among all the data scientists, like all the programming language used by data scientists and AI researcher. And definitely I'll give one reason. There is one particular slide which gives you an advantage of data, like why Python is getting popular more. Out of these four components, one which is very important from the industry perspective, where students do not spend time, that is data and the domain. Your data understanding. Even if you want to write a paper in the field, you need to understand the data part. You have to explain what type of data you have picked and why do you picking that, like why did you pick that data. Then only you can look at the different algorithms or use the different algorithms which are there in the machine learning or deep learning. So very important, the core concept, the domain should be there. Okay, so the another very important slide, and I want to make it more interactive. So few of the applications from different industry I have mentioned over here. Definitely it's not an exhaustive list. Few of the application I have mentioned here. So if you take example of marketing, in marketing there are two different strategies like upselling and cross selling. Everybody knows about that. So cross selling, where you are adding another product with the primary product, like MACD. They do a product bundling where Pepsi is being sold with the burger. They make combos, right? So that is a cross selling strategy where you are bundling the products together and giving some discount so that you can increase the revenue you are getting from the customer. So cross selling. Now what type of product which will get bundled together, how will you get to know? Based on the data mining technique like market basket analysis, right? Market basket analysis, association rules. So this is one of the very critical concept in data science, in data mining, which we use to bundle the product together to understand which are the product bought together by the customers. Now if you look at upselling, upselling is when you make your customer to buy expensive product. Let's say I wanted to buy a Samsung product. I went to the Amazon going through the Amazon, like for Samsung mobile, Amazon give lot of recommendations where you will see like you can buy. There are a lot of features which you will not find in the Samsung. You will find in the Apple iPhone, for example. So ultimately, you will be ended up buying the iPhone. So that is upselling. You wanted to buy a like 20,000 phone, but you ended up buying 50,000 phone. So that is upselling. How companies make that? Based on the features, based on recommending the features, right? So upselling is another very important concept in marketing, which is being used to get more revenue from the customer. And that is happening because of the recommendation. So Amazon mentioned that 40% of the like revenue they generated through recommendations. OTT like Netflix, Amazon Prime, or AdTech like in Z5. If you have not subscribed, you will be able to watch the videos, but there will be ads played, right? So now videos recommendation and ads personalization. So these are the critical concept which I am working on right now. Video recommendations on Z app or Netflix, you get lot of recommendations. Now there are algorithms behind those which try to understand the user behavior. So let's say I have watched Salman Khan movie in the past. Let's say out of 10 movies, I have watched 7 movies of Salman Khan. Then algorithm will automatically understand that I am a fan of Salman Khan, right? And then in the recommendations, it will incorporate Salman Khan movies. Very simple example of recommendation system. But there are very sophisticated recommendation system based on deep learning like contextual, and now reinforcement learning applications are also coming into recommendation. Like you might have heard about multi-armed bandit models, which are very helpful in cold start. If a particular customer is new, we do not have the data of the new customer. Very interesting problem in the recommendation field, guys. And if you are like interested in writing papers, lot of research is happening on that side. If you are interested, you can connect me later after this session. We can have a detailed discussion on that particular side, that cold start, when we do not have any data of the customer, then how we can give the recommendations. So that side we can talk about, right? So there are reinforcement learning algorithms which are being utilized in this particular area. Ads personalization, again based on the customer watch history, user watch history, we do the ads personalization. Now ads personalization is very interesting. Now what I have seen as of now, there are static ads you will see on the YouTube or any OTT platform. But what where future is heading, or you can like anyone interested in the research side, they can pick this particular area, how we can incorporate the ads in the video itself. As of now, what happens in the on the YouTube, if you take example, they have to stop the video to show you ads. But can we show the ad of a particular brand in the video itself? Let's say there is a movie going on and there is a building in that particular movie. Can you show the name of a particular brand over there on the building? It's your original video where you are putting the ad inside the video. You do not need to stop the video for that purpose. This is where like the ad tag is going, right? And this is very interesting one. You do not have to like make the user experience bad, but you are still able to give the ads, right? Very interesting, very fantasizing like application of ad tech. Credit and insurance customers who are going to default before giving you the insurance, they know about you, they have your transactional data, so they predict in the future that whether you are going to claim the insurance or not, and if you are going to claim, how much you are going to claim. So that models are there for last 10 years, and definitely lot of research happened on that side. Sales, demand forecasting, and discount offering, how much discount should be there on a particular product, that is being like 5%, 20%, 15%, all of that number is being find out by analyzing the data. That I have done personally in JFL. Like for the Domino's, you get 20% off or 25% off. Now, how this number is coming up, that 25%, and as of now, it was more on the static side. For like a lot of people will get the same coupon, but we were working on the personalization side. Like everyone will get a different. Like one is getting 20%, another can get 25%, to make more revenue out of the customer and like keep our customer engaging. Demand forecasting the demand of a particular product so that we can analyze or we can maintain the inventory of the product. Social media recommendation system, sentimental analysis. Recommendation system, you already know. You go to Facebook, friends you may like, or the different news feed, all those recommendations are coming, right? You take example of LinkedIn, different connections you make through recommendation on Netflix, YouTube. So recommendation is everywhere around us. Sentimental analysis, this is another very critical example of application of data science, where we try to analyze the sentiments of the customer about a product, whether the customer is positive, negative, or neutral, right? Based on the text analytic, lot of algorithm, lot of research happened over there, and we are able to perfectly analyze the customer preferences, whether customer is positive about Domino's brand, negative about the Domino's brand, or it's like neutral about the Domino's brand. That customer can move to any other, it's just the pizza, right? E-commerce supply chain model, very critical aspect of Amazon. They need to manage the supply chain, how the product can be delivered to the customer within optimized time with the optimized cost, right? So that is a supply chain. Customer churn, whether customer is leaving your company or product or not, that will come under customer churn, right? Lot of application I have mentioned over here, and I hope this is clear that data science is everywhere. Click, sir.
Mohit sir, in defense sector or to prevent the terrorism, how data science is helpful?
Okay, I'm not like aware lot of applications. One of the, because I read a lot of papers every day. One of the paper I was reading like last month. So the target, so it is more on the attack side, terrorist attack, or like the how the weapons are getting smart, right? So the paper, there was a paper, how we can optimize the target. When you shoot through a weapon, that target, like it will definitely hit the target whichever being set through the weapon. Now on that side, AI is working. Definitely, I was reading through the paper, there was algorithms who are helping to set up the target over there, and it's highly accurate, it will not miss. So there was some accuracy also, I don't remember that, but along with 99 plus accuracy, so it was able to hit the target. So that is a classic example, like how data science application or AI is being utilized in defense also. Apart of that, there are other like CCTV footage, right? You can implement or remote these drones, right? So we have different drone because there are a lot of remote areas where human beings cannot go. We can use different drones, and lot of industry also trying to implement the drones in their business. Like you might have heard, drones will be used for the delivery purpose in the future. Ola has invested a lot of money into that side. Similarly, Amazon is also like, they have a particular team who is working on the drone side, delivery. In India, it will be difficult, as you know about the surrounding, but definitely in the like there are a lot of demos are happening outside India, right? So drones can be utilized in sensing the remote locations, and in the real time, drone sends the data. We analyze in the real time those data, right? Different applications, like I told.
Okay, sir. Thank you.
Simple example, like we already see. So last slide, sir. Just move to the last slide. Yes. So again, very common examples of deep learning and machine learning. Everyone would have, like, a lot of you would have communicated with the assistants. It may be like a Google Assistant, Siri, Echo Dot, right? Lot of assistants are there. You can interact with them. Now try to understand the back end of this, how these technologies are working. When you are communicating with them, definitely speech to text, then text analytics, coming back to recommendation or the actions. So all of these are part of machine learning, right? Similarly, machine translation, YouTube, Google, even in our Z5, we are working on subtitle creation. And then those subtitles can be translated to any language based on the demographics, right? Again, very critical example, like text analytics, NLP, natural language processing. Now, because we have lot of data we are generating in the form of text, NLP is getting very popular, and there are a lot of models which are helping you. Like you might have heard the recent BERT, robot, all of these are happening. All of these are models, state of the art models in the NLP side. Our Gmail, spam, not spam, Facebook, photo tagging, as I already mentioned this particular example. So yeah. So next slide, sir. So everyone, like, if you are working on a particular application, you want to talk about it, definitely we can talk about it right now also, like in short usme. Otherwise, like if you want to discuss, definitely I'll share my mail ID and we can connect over that as well. So my past ML projects, a lot of things I have already told. So I don't think, like, related to demand forecasting, time series forecasting I have worked on. I have worked on machine learning, supervised modeling part. I have worked on market basket analysis, NLP, log file in analyzer. This was very successful, and I like published one paper on this as well, log file analyzer. So if I talk about a bit about this, so when I was working in Siemens, we had different machines, healthcare machines like ultrasound or MRI machines. Now, whatever happening with the machine, that is being dumped into a log file. It's a simple text file where you are dumping everything. Because later, if there is something bad happened with the machine, how will you be able to understand? Every engineer able to understand through that log file. They read that log file and they try to understand what is happening with the machine, what is wrong with the machine. Now, what was happened before my project in the Siemens, it was taking more than 100 days to solve a simple problem in the machine happened. In like any hospital you take, like Fortis, if there is a problem with the machine, it was taking more than 3 months to solve that particular problem. But then this project came and we started to working on this particular project where we were trying to understand, we were building a system which can understand the log file and give up like the recommendations that these are the potential problems with the machine. Then engineer will not have to spend lot of time on that particular log file to just find out the problems. So because like 60 to 70% of the time was going into finding out the problem, and that was the like achievement we made, that through the system we were able to analyze the log file and give all the potential problems within a minute itself. So we were able to reduce that time from 100 days to 30 days, and that remaining time was only to implement the solution, not for the analysis part or identifying the problems with the machines. So this was the best example, like I have worked on the NLP side and it was a success. I hope you can understand, like from 100 days to 30 days, how fast we made. And this is like this particular example made the like our company Siemens became better in that particular area because we had a lot of competitors in the field. So this is how we improve the customer experience So for the Siemens, hospitals were customers. So we were improving the customer's experience, and that was giving us the competitive advantage over other companies, right? So again, customer segmentation, finding out your, like segmenting your customers based on the revenue, based on their preferences, based on their behavior, right? So all of these you can do that through machine learning unsupervised problems. I'll just touch upon those algorithms, supervised and unsupervised, in a bit. Then image classification, you already know, like CNN, convolutional neural network. These are the variants of artificial neural networks which are very successful in the field of computer vision, right? So yeah, next slide, sir. So I'll just quickly go through this machine learning part, right? Because I am just hoping that everybody knows about this. So what happens? As a human being, we learn from our experience, right? We do mistakes and we learn from our experience. In the past, all the machines, we had given the instructions, right? In the past, if we talk about the machines, we were giving the instructions through the code, and they were able to perform one particular action based on the instructions we had given. Now, what is AI? We are making our computers, they to learn them from the experience using machine learning, right? So we are making our machines to learn from the experience. Now you will ask, what kind of experience? They don't have any experience. We are passing the experience in the form of data, right? Because past data, they learn from that data different patterns, different insights. So what they are doing, they are learning from the experience or from the data, and they are generating the recommendations. So that is the whole idea of AI and machine learning right now. Machine learning is the field of study where we are giving the computers the capability to learn without being explicitly programmed. In the past, we had the program, like if you talk about any computer machine like AlphaGo or the Go, right? So AlphaGo was a machine who were able to defeat the like world's best Go player. But that machine was not an example of like the AI we are building, because that machine was very much capable of performing only one task, playing Go game. But like being human, we can perform multiple actions. That skill was not there in the past, but now because of all these advancements I talked, we are able to give that capability to the machines that they can learn themselves. We do not need to give instructions to them. So that is the idea of machine learning. Now there are different type of machine learning problems: supervised, unsupervised, semi-supervised, reinforcement, right? So let's talk about supervised and unsupervised. Reinforcement, it's more on the learning from the past, taking actions, getting rewards, and either rewards, if the action is on the successful side, then definitely it will get the reward, and if it is on the negative side, like then it will then the machine will get penalized. So based on the actions and the feedback from the environment, reinforcement learning is built around that. Classic example, you take example of like different games over there. Those games are built around reinforcement learning. Like PUBG, you would have seen there are computers or bots. Those bots are built using reinforcement learning, right? Because there they are taking actions, they are getting penalized. Like in recommendation system, as I said, cold start problem is a very significant problem. Everyone is struggling in that area. Lot of research is happening, and it will keep on like going. The research is definitely going on. So multi-armed bandit is one of the reinforcement learning which is being utilized in like in all the games as well as in the recommendations. So semi-supervised, which is half supervised, half unsupervised. Once I talk about supervised and unsupervised, then I'll talk about it. So next slides. So supervised, I'll just quickly go through. In supervised, what we do, we pass data along with the labels to our algorithms. We tell this is the data and this particular data belongs to this particular label. So like we are passing an image of the apple and banana. Very simple example, passing images of apple and banana, and we are specifying that this particular image is apple, that is a label of the image, right? Similarly, this particular image is a banana, again giving a label. So we are passing images, which is data, and the label specifying it's an apple or banana. So we are passing input data along with the labels. Our machine is learning or getting trained on that data and finding out the patterns. Like it will try to find out how my apple looks like. It's a orange color, oval shape. Similarly, for banana also, it will find out the similar patterns, similar insights, and it will be able to learn that, okay, in the future, if I get any particular image which looks like this, then it will be an apple or it will be a banana, right? So this is how it happens. So the critical part is, along with the data, we pass labels. So supervised learning is a type of machine learning algorithms in which both input and desired output are provided to get model trained. Next. Supervised, further classified into regression and classification. Regression, where we are predicting the target continuous variable. Classification, where we are predicting the class variable. So like whether customer will like click on a particular ad or not, whether customer will will buy the product or not. So if I talk about one of the example, like, okay, how much customer will claim on a particular insurance, that particular one, please give me the answer in which class it will be lying on, whether it will be a classification problem or regression. The problem is how much customer will claim on a particular insurance. Absolutely, Prashant sir. It will be regression problem because we are predicting the target variable which is continuous. On the classification, we will be having classes, 2 or more than 2 classes definitely, but we will have more than, we will have classes. So absolutely. Next slide. Unsupervised, where we are passing just the data without labels. It will analyze, find out the patterns, which are the points. Simple example I have taken, the clustering techniques, where it will try to find out the similar items and it will club those similar items into clusters, right? So like apples look like the same, they have the similar patterns, so they will be clubbed into one category. Similarly, banana will be clubbed into one category and mangoes will be clubbed into one category. This is a classic example where we use like customer segmentation. Customer segmentation is classic example of unsupervised machine learning technique, clustering, where we have different algorithms like k-means. Lot of algorithms are there. K-means, k-medoids, a lot of improvements, right? Next. Okay. This is, I'll not spend much time on this, but this is very critical from data science, whether you are writing a paper, whether you are into industry, whether you are working on a data science project anywhere, you have to follow these steps. These are the 6 steps which everyone has to follow. Always your first step will be identifying the problem. Whether I am working on a particular problem, let's say a particular bank losing revenue because customers are defaulting. So first I have identified the problem, business problem, that customers are defaulting on a particular loan. That's why I am losing the revenue. So now I have defined the loan. I have defined the the business problem. Around that only we will collect the data. So our next step, collecting the data, will always depend on the first step, which is identifying the business problem. Now, as the second step, where we are talking about collecting the data, the data can be anywhere. So like data can be in a database, relational database, it can be on the clouds, it can be over internet. Like in our personal G5, what we do to get more information about the item or the movie, we get data from IMDb also. So on IMDb, for every movie, they have a lot of metadata. So we collect that data from IMDb. So we use web scraping techniques to get that data from IMDb. So that also a part of data science project lifecycle, because we have to collect the data. It can be anywhere. So collection part, again, in lot of projects, it will be a critical aspect of it, because collecting the data, always you try to get more data. Within the second step, once you collect the data, you have to prepare it, you have to clean it, because you'll never get the clean data in the industry. We always have to clean the data. Now there are a lot of steps in cleaning, data cleaning, like missing values, outlier. There are a lot of invalid inputs. For linear regression or logistic regression, you may have to use the transformation, right? Based on the modeling part, you have to understand whether you need to transform the data or not, because for linear regression, you have to make the normalized variable. So for that, transformation is also required. And like that, there are a lot of different data pre-processing steps you have to follow. Once we have our data prepared, the next step moves to the building a model. So next slide. Next slide. So data preparation steps I have talked about. Yes. So building the models, on the right hand side, you can see I have like, it's a very beautiful pic where you can observe all the algorithms. Not all, but definitely important algorithms which is being used in the industry. So machine learning problems are classified into supervised and unsupervised. Then supervised are further classified into classification and regression, as we discussed. For classification, we have different algorithms. For regression, we have different algorithms. There are a lot of algorithms which can be used for both, like decision tree can be used for classification as well as regression. Similarly, the variation of decision tree, like random forest, or all the ensemble techniques like random forest and boosting techniques like XGBoost, all these techniques can be used for regression and classification. But first we have to understand the data, and then we can understand which type of technique we can use. Similarly, on the unsupervised, we have clustering, very interesting one, as we talked, right? So the next step after building the model, you collected the data, we have pre-processed our data, we have to build different models. As we know, in the data science, we have a free lunch theorem, right? There is no one perfect model for all the data set, right? There is a very popular theorem, no free lunch theorem. So it means there are no one model, there is no best model for all the data set. We have to try out different models, and then we have to evaluate them. That is our fourth step. We have to evaluate the performance on the model, on the test data, or you can use cross validations technique, right? And then you can identify which particular model is performing best on the data set. So that is our fourth step. At the end, you can club the fifth and sixth step, but in industry, we always present our results, and then we deploy. Once we get the permission or approval from the like top managers, then we deploy. So in the industry, there are 6 steps. From academic point of view or paper point of view, definitely 5 will be sufficient. Once you have built the model, evaluated it based on the approach of your paper or academic goal, you can club these two. Deploying part will not be there, as like I have seen, but presenting it in a right manner, that's a critical part of data science project lifecycle. So these are the 5 different steps, definitely very important, and we always follow them. So quickly 2-3 slides forward, sir. Follow. Yes. Data science toolkits. So lot of, as you know, data science is very dynamic. So today we are using one technology, next day it becomes obsolete and we use another technology, right? So earlier it was R, which was very popular, R programming language, but now lot of industry have moved to the Python side. Now in the future Python will be there, but definitely a lot of applications are moving around Julia or maybe like a Scala. Okay, I have one question over here. So Dr. Ankit have asked, how can we evaluate the performance of a model? So that is a very interesting question. It will depend on the type of problem we are solving. Like if I talk about the classification machine learning problem where we are predicting the classes, we have different evaluation metrics. Like you might have heard about accuracy, you might have heard about area under the curve, right? Then we have like different, if you have imbalanced data set in that side, then we use precision recall, right? So these are different techniques. Definitely, like it will depend on the problems we are the machine learning problems we are solving. Now if we talk about the regression side, in regression we have different metrics like root mean squared error. We have Akaike information criteria, AIC, very popular one. For linear regression, you might have heard about like R square, right? Similarly, mean squared error. For time series, we use mean absolute percentage error. So it is the algorithm which decides what type of performance metric we are going to use. In case of unsupervised machine learning, the evaluation becomes very challenging. Like if you talk about the clustering part, a lot of people struggle with that, right? Even we struggled when I worked on this particular problem in the industry. Even we struggled to find out the accuracy of our clusters. We made the clusters of our customer, but we were not able to, because that is the not drawback. It is a challenge in unsupervised machine learning. You have to conduct. So for that purpose, we use A/B testing technique to evaluate the performance of unsupervised machine learning problems. So A/B testing is one technique where we split our customers into two groups. One group will see the same part, right? And there will be another group where we will have the different data which will be shown to the user. And then we compare the performance of two groups. Whichever perform better, that will get a better, like that will be the final result of the model, right? So A/B testing is one technique we use in case of unsupervised. So I hope it is clear that it is your problem, machine learning problem we are trying to solve, which will give you the which will decide your evaluation metric. Did I answer your question, Ankit sir? Okay, thank you. Yeah, so we were talking about data science toolkits. It's a very interesting slide because a lot of people get confused ki which programming language to use. And based on my like earlier sessions, I have included that as well. So in the next slide, I'll talk about why Python is the future. So in the here, based on the 6 steps we have talked about, based on that, I have mentioned all the tools and technology over here. So database management, because our data will be stored in one of the database, right? So for that purpose, we need to understand the SQL. That is very important technique from the industry perspective. I am talking as from industry perspective. I have seen in the academics, like you are like we can use MATLAB. We have like SAS, SPSS also being used in academics, but in industry, I have like personally, I have not seen in 5 or 6, 7 companies I have worked on. I have never seen anybody using SPSS or Stata or MATLAB. I have already like I have seen using R, Python, Spark, PySpark, right? But never all these techniques. But in academics, there are like universities which still use these technologies like SPSS, Stata. But I would say yes, in the industry, Python is more popular. And from the research side also, lot of research happening on the Python. Last slides, please. Last slide. So database, definitely SQL and NoSQL. Then on the programming, because we have to manipulate the data, we have to collect the data from different sources. So you need a programming language for that purpose. R, Python you can use. Statistical tools or machine learning. Again, in R we have a lot of libraries. Similarly, Python also we have a lot of libraries. One of the state-of-the-art library like scikit-learn, it is there in Python, which have all the like most of the algorithms are being covered in that scikit-learn library. For the visualization, both are good, R and Python. R is bit better in visualization because I personally worked, this is my experience. So I have worked on ggplot2, which is quite very user friendly as compared to the Python matplotlib library. So R and Python you can use, or there are tools over there as well for the visualization like Tableau, ClickView, all of those. So those can be used for the visualization purpose. Then machine learning tools, again we can use R and Python or any programming language for that. Yeah, next slide. So this is based on the requirement from the industry. So this is going to be very helpful for all the faculties, because ultimately which programming language or which tools your student should be working on, this particular slide gives you that feel. So on the programming side, definitely Python. So these numbers, these percentage are being taken from the job perspective. All the job listed out there in the market, how many out of those required the Python programming, Java or R. So as you can see, all the data science related listings out there, 17% of the listings required Python programming language. Then it was Java, then R, SAS, SPSS, MATLAB. So the first one is definitely Python. Then dashboards, to create business intelligence dashboards, we have Tableau, which is a major player in the market. It's a paid one. For student it's free, but in the market we always prefer to get the paid one, and it's very expensive. That is why a lot of industry move to this Power BI or ClickView as well. Right. Then big data skills, Hadoop is the major player definitely. Then we have like Spark. Spark is more for the data processing, big data processing. Then Hive for the relational database, but on a big data side. Then MapReduce again for the data processing, which is being implemented using Java. So that's why people find it difficult to use MapReduce. That was the reason why Spark is getting very popular, because Spark, there you can use multiple programming language like R, Python or Scala or Java. Anyone who is comfortable with any of these four language, we can still use Spark. Then concept side, segmentation clustering. So like every algorithm, every concept has their applications. It depends on the industry. So cloud services, there are a lot of cloud services, AWS, Microsoft Azure, Google Cloud. Then every like next Alibaba, they are actually coming into the cloud services, Oracle Cloud, but the major player is still AWS. So like I have seen people are getting jobs just because of the AWS skills. Then databases, definitely it's still the SQL, because a lot of companies, they have dumped their structured data into SQL databases, relational databases. So SQL is must. In all the 5 companies I have worked upon, I have used SQL for that purpose. Now there are few companies like in Siemens Healthcare, we had the unstructured data, so we were using MongoDB as well. So NoSQL database also getting popular, and in the near future they will also boom. So among different aspect of the data science field, we have the major player which are leading the market. So yeah, next slide. R versus Python. So like a lot of time people ask me this question, so I am just quickly explaining this part. So both of them are good. I never like prioritize one over other. I have worked on, like I have more than 5 years of experience in both the languages, R and Python. So based on my experience, I have listed down all these points. So customer support is good for both R and Python. So if you have any error, you can go to online and you will get the answer for that particular error. Structured data analysis, I have felt it R is quite better, because there we have like different libraries, dplyr, and it's quite user friendly to manipulate the data in R. But because of the pandas in the Python, structured data analysis become very easy using Python also. Text mining, where we talk about the unstructured data, I personally feel Python is much better. There are a lot of supports, a lot of libraries like NLP library, NLTK library is very good. You will find a lot of solutions related to text data in that particular library. So I would say, I personally feel for the unstructured projects, data projects, Python is quite better. Speed, might have already heard, like Python is faster than 5.8 times faster than R, because a lot of the code written in Python is in C language. Data visualization, I feel R. Deployment, definitely Python, because of Django and Flask framework. A lot of frameworks are there in Python for the deployment, web deployment or app deployment. Python is far better than R. Still, like software engineering side also, I feel Python is much better. Next. So Python, why it is getting very popular? So if we compare 2021 and 2022 July data, so Python is in July 2021 based on the searches over different search engines. This rating or this ranking has been done. So now July 2021, it was on third rank. C was the first. But July 2022, now Python is the number one with ratings 13.44%. And definitely it's booming. Number of questions over stack flow. On the left hand side, number of questions on the stack overflow. This is very important to get the support of a programming language. If you are struggling, if anyone is struggling with any particular error, it will be quite difficult to find the solution by itself, right? We need a support for that purpose. So if you take this orange line over here, number of questions on the stack overflow, they have increased exponentially, which suggests that definitely there are a lot of supports. For all other programming language, you can see the numbers are declining. You take example of JavaScript, you take example of C, C#, R. For all of them, it's declining. And for R, it became constant. Since 2018, the number has become constant. But for Python, it's still exponentially growing. So Python, definitely. The next, different roles in the industry. So data analyst, data engineer, data scientist. First, we'll start with the data engineer. So next slide. Yes, so engineer will be working more on the data collection side, data storage purpose, right? So now for the storage purpose, as we know, we are moving towards the big data technologies. So every engineer need to understand the big data technologies like Hadoop. All the technology comes under Hadoop, like Spark, like HDFS, MapReduce, Hive, right? All of these technologies one need to understand to become data engineer. Next, clouds, because we are not storing, we are not creating our clusters, but we are utilizing the clouds from different organizations like AWS or Google Cloud. Personally, like we were in the G5, we were on AWS. Now we are planning to move to the Google Cloud. So every company, they are moving towards the Google Cloud. Moving towards the cloud services now. But AWS is still the major player. Now coding skills, definitely, because our lot of big data technologies are written in Java. So I would say Java should be the primary language for all the data engineer. Still, I have seen people are moving in the data engineering side using Python also, but Java still remains the like at the top because technologies are built around Java. So Linux, all of these Hadoop clusters are built around the Linux operating system. So one should be comfortable with this. SQL, NoSQL both. Now for the collaboration purpose, definitely we need to have our GitHub for the versioning purpose, code versioning purpose. So these are the different skills data engineer should be aware of. Data and business analyst. So a lot of time people ask, what is like data analyst and business analyst? What's the difference? As of now in the industry, there is no difference. Based on my experience, I have worked as a data analyst in Siemens. I have worked as a business analyst in Infosys. Now I've worked as a data scientist. Currently, I'm working as a machine learning engineer in G, AI researcher. So I have been into all those field and designations. So data analyst and business analyst, there are not much differences. Generally, we call that data analyst will be working more on the data side and business analyst will be working more from the business perspective. So generally what happens, business analyst will be taking the requirement from the businesses. They should be good with the business data domains, and data analyst should be good with the data. He should be very much comfortable with all the algorithms, all the techniques to analyze the data. But along with that, business analyst should have the business domain also. Okay, for that purpose, we can use like SQL because our data will be stored over there, or NoSQL. Data collection will be done. Then we need a coding skill of Python or R to get our data clean and building our models and all those. For visualization, again, Python libraries or R libraries. On the skill side, machine learning, predictive statistical modeling, statistics, communication skill, as well as business skill also required. Definitely for all the roles, business skills and communication skills are required. And dashboards also, because ultimately we present our data in the form of dashboards, Tableau dashboards, or we can create dashboards in Excel also. So very critical tools for data analyst or business analyst perspective. Next. So I'll just take 2 minutes, 5 minutes more. So data scientist, combination of data engineer and data analyst or business analyst, right? So combine all the skills of data engineer and business analyst or data analyst, you'll get data scientist. So generally is like a godfather of analytics field, analyst, right? So all the skills from the deep learning, NLP, computer vision, all of those needs to be covered. Data analyst technologies like R or Python should be comfortable with engineering skills and cloud services. Then for the code versioning, GitHub. Next slide. Okay, last 2 slides. So I'll just quickly go through these and then we can have questions as well. Okay, so AI versus ML versus DL. So AI is like an umbrella. Just imagine AI is an umbrella. In that we have multiple technologies like robotics, which comes under AI. Take an example of Sophia. What all tasks we can that Sophia can achieve? She can speak, she can move, right? She can give the answer. So the brain of the Sophia is built around ML. Machine learning is responsible behind that. Okay. Now, so AI is an umbrella. In that one component is machine learning. The brain of every AI is machine learning. In the machine learning, we have lot of varieties of algorithms. One of the very like neural network, which comes under machine learning. The field around neural network, artificial neural network, makes our deep learning models, deep learning field. Okay, so AI, machine learning, we have multiple algorithms. One of the algorithms is neural network. When you make a very deep neural network, that will start coming under the deep learning. So all the variants you talk about, CNN, RNN, LSTM, BERT, robot, all are nothing but the variations of artificial neural networks, which made or developed for a specific purpose. Let's say if I want to, if I am working on image data, then I'll be using CNN more as compared to other algorithms. If I am working on text data, I'll be working more on the RNN or LSTM side or BERT side. So all the variations of neural network comes under the deep learning side. So I hope this particular pic is clear to everyone. Next slide. So different DL applications. So we were talking about the machine learning part, but in the specific to deep learning, we have three areas. One is computer vision, where we are more working on the images side, like image classification or object detection. It's a perfect example of like autonomous vehicles. In autonomous vehicles, the cameras are there. They are capturing the live frames of the videos, like the front videos in the real time. It's actually analyzing those frames and trying to understand whether it has to take the right turn, left turn, is there any object in the front, is there a signal out there, right? And based on the signal input, they take the decisions. So that autonomous vehicle, it's able to achieve all the tasks related to the image side. Like human beings, we drive all the related to the all the tasks we achieve using like through the vision. Those are happening using computer vision side, right? So though like there are multiple algorithms, lot of variations of CNN, you might have heard about LXNet, then ResNet, all these algorithms which are there, they are very helpful in computer vision. There are other applications also, like object detection. In a particular image, it's not identifying who is there as well as where it is there in the image. Like in the front image, let's say if autonomous vehicle we are driving, autonomous vehicle, it has to identify where is the object. It needs to use the object detection algorithm like YOLO. YOLO V7 version 7 is now published in 2022, right? Which is very accurate. Lot of applications in healthcare, computer vision. Like we are able to analyze the X-rays, MRIs through the algorithms, and they are quite accurate than even doctors, right? So computer vision is more onto the images or videos. Speech and audio, like you communicate with the assistant, Google Assistant or Siri, you speak with them. In the backend, it actually converts that speech into text, and then it tries to analyze, right? So speech and audio as well. Based on the audio, now systems have built which can predict the age of the or the gender of the communicator, right? Now this can be very helpful in different industries. Now customer care center, right? Now in customer care center, they can understand who is what is the image, what is the age of the user, and then the different tones of the speech. All of those applications comes under this speech and audio part. And the last one is natural language processing, very popular already. So in natural language processing, we talk about the text data, and we try to understand or try to analyze the text data like BERT, robot, RNN, LSTM, all of them, all of those variations of neural network models comes under this NLP. So these are the different applications which are out there in the industry related to deep learning. So I think I'm done from my side. So if you have any question, please ask. If you have any feedback that we could have talk about some other topic as well, it's welcome. So I am happy to take that. So any feedback, any question, any doubt, I'm open.
Yes, please, everyone. Now it's open for discussion. So there is question in chat box by Ankit.
So, okay, what is the role of decision matrix and how it is used? So there are a lot of decision matrix. Be specific, like, because from the industry perspective, decision matrix, like different quadrants we use. So like from what perspective you are asking, Dr. Ankit? Can you be more specific on that side?
Mohit sir, what is the basic difference between classification and clustering?
Okay, so in case of, first of all, both are different field altogether. So classification comes under the supervised machine learning problem, and clustering comes under unsupervised. So in case of clustering, we do not pass the labeled data. We just pass the data and it tries to analyze the pattern and get clusters out of it. We do not know that this particular cluster, which property it inhabits. We try to understand, we try to analyze the clusters, then we give the name to it. But in case of classification, we already have the classes which we are predicting whether the customer will buy the product or not. Here the class is yes or no. That class does not exist in case of clustering problems. There we have all the data and we dump it. So these two problems, like algorithm, the problems are different altogether, right?
Yes, any doubt, any question you want to ask?
Thanks, Neeru. Thanks, Prashant, sir.
I think there is no more question because your session, your presentation was very good. I think it is the best presentation that I have seen in my academic life. You started from very basic, what is data science, why it is used, what is machine learning types, different life cycles, what is the requirement of industries. So I think from starting to end, complete detail was there. So that is the best, I think, I must say it is the presentation that I have seen related to data science and what are the requirements, how the students can also prepare, what skills students also need. So thank you, sir. Thank you very, very much.
Thank you. Thanks. That means a lot to me as well. It inspires me.
Definitely, sir. It was very nice presentation. And from on the behalf of Chandigarh University Academic Grade 1, I'm very much thankful to you for sharing your time and
Thank you guys for watching the video till the end. I hope you liked the video and you find it informative and useful. So this was from my side, guys. Now what I want from you, please mention in the comment section which topic you like the most, and if you have any topic in your mind which you want me to talk about, so mention that as well. So don't forget to like and subscribe my YouTube channel, guys. Thank you guys. Bye bye, take care and stay tuned till the next video.